The 1976 National Electrical Code, or NEC, permitted the use of multiple ground fault circuit interrupter, or GFCI, outlets on a single circuit. However, it required that the circuit be dedicated to GFCI outlets only and not shared with any other loads. The current NEC, the 2020 edition, requires that in bathrooms, at least one GFCI outlet must be provided for all outlets that are not part of the bathroom lighting circuit. In kitchens, GFCI protection must be provided for all countertop outlets and those within 6 feet of the sink. GFCI outlets must be on a dedicated circuit or be installed upstream of other loads. An inspector's assessment of a home electrical system may reveal several issues. Firstly, the inspector may determine that multiple GFCI outlets are on a single circuit. While the 1976 code allowed multiple GFCI outlets on a single circuit, current code requires them to be on a dedicated circuit. Secondly, the inspector may determine that the GFCI circuit is shared with other loads such as lighting. This is a violation of current code requirement. Thirdly, the inspector may determine that there is insufficient GFCI protection in bathrooms. If there is only one GFCI outlet in a bathroom, additional GFCI outlets may be required to comply with current code. To ensure compliance with current code and safety standards, it is recommended that a dedicated circuit is installed for the GFCI outlets in the bathrooms, kitchen, and exterior. It is also recommended to add additional GFCI outlets in bathrooms as needed to meet current code requirements and inspect and verify that all GFCI outlets are functioning properly. It is important to understand the specific requirements of the electrical code to ensure safety and compliance, especially during a home sale. GFCI outlets are designed to protect people from electrical shock by monitoring the current flowing through a circuit. If there is a difference in current between the hot and neutral wires, it indicates that some current is leaking to ground, which could be through a person. The GFCI outlet quickly trips, cutting off the power and preventing a potentially fatal shock. The 1976 NEC allowed for multiple GFCI outlets on a single circuit, but this practice is no longer considered safe or compliant with modern standards. The reason for this change is that if one GFCI outlet trips, it can shut off power to all the other outlets on the same circuit, which can be inconvenient and potentially dangerous. For example, if the GFCI outlet in a bathroom trips while someone is using an appliance, it could cause the appliance to malfunction or create a hazard. Current code requires that GFCI outlets be on a dedicated circuit so that if one outlet trips, it does not affect the other outlets. This provides a higher level of safety and convenience. In bathrooms, the current NEC requires that at least one GFCI outlet be provided for all outlets that are not part of the bathroom lighting circuit. This means that all outlets in the bathroom, except for those that are used for lighting, must be GFCI protected. The reason for this requirement is that bathrooms are considered to be wet locations, and the risk of electrical shock is higher in these areas. GFCI protection helps to reduce this risk. In kitchens, the current NEC requires that GFCI protection be provided for all countertop outlets and those within 6 feet of the sink. This requirement is similar to the one for bathrooms, as kitchens are also considered to be wet locations. Countertop outlets are particularly vulnerable to water exposure, so GFCI protection is essential. If an inspector finds that a home does not meet current GFCI requirements, they will typically recommend that the homeowner make the necessary upgrades. This may involve installing new GFCI outlets, adding dedicated circuits, or both. It is important to address these issues before selling the home, as they could be a deal breaker for potential buyers. In addition to the specific requirements for GFCI outlets, the NEC also has general requirements for electrical safety. These requirements cover a wide range of topics, including wiring methods, overcurrent protection, and grounding. It is important to be familiar with these requirements to ensure that your home's electrical system is safe and compliant. If you are unsure about any aspect of your home's electrical system, it is always best to consult with a qualified electrician. An electrician can inspect your system, identify any potential hazards, and make recommendations for repairs or upgrades. By taking these steps, you can help to ensure the safety of your home and family. The electrical codes are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest code requirements to ensure that your home's electrical system is safe and compliant. There are many resources available to help you learn about electrical codes, including the NEC, online forums, and educational courses. By taking the time to educate yourself, you can make informed decisions about your home's electrical system and protect yourself and your family from electrical hazards. When evaluating the electrical system in a home built under older codes like the 1976 NEC, it's crucial to understand how those codes differ from current standards. This difference highlights the evolving understanding of electrical safety and the improvements in technology designed to protect people from harm. The move towards dedicated circuits for GFCI outlets is a prime example of this evolution. While sharing circuits might have been acceptable in the past, the potential for nuisance tripping and the interruption of power to multiple areas simultaneously led to the requirement for dedicated circuits. This change ensures that a single fault doesn't cascade into a larger inconvenience or safety issue. The specific requirements for bathrooms and kitchens reflect the increased risk of electrical shock in these areas due to the proximity of water. The 6-foot rule for kitchen sinks is intended to cover the area where water is most likely to be splashed or spilled, increasing the chance of contact between water and electrical appliances or outlets. The recommendation to install dedicated circuits for GFCI outlets in these areas is not just about meeting code, it's about providing a high level of protection for the occupants of the home. When inspecting and verifying that GFCI outlets are functioning properly, it's important to use a GFCI tester. This device simulates a ground fault and verifies that the outlet trips as expected. It's also important to visually inspect the outlets for any signs of damage or wear. If an outlet is damaged, it should be replaced immediately. Addressing GFCI issues before a home sale can prevent delays and potential renegotiations. Buyers are often concerned about the safety and functionality of the home's electrical system, and any issues in this area can raise red flags. By proactively addressing these concerns, the seller can demonstrate that they have taken good care of the property and that it is safe for the new owners. Moreover, compliance with current electrical codes can also increase the value of the home. Buyers are often willing to pay more for a home that is up to date and in good condition. In addition to GFCI protection, there are other important aspects of electrical safety that should be considered. These include proper grounding, overcurrent protection, and the use of arc fault circuit interrupters, or FCIs. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Overcurrent protection, such as circuit breakers and fuses, protects the wiring from overheating and causing a fire. FCIs detect arc faults, which are a common cause of electrical fires. The NEC requires FCIs in many areas of the home, including bedrooms and living rooms. When making electrical upgrades, it's important to use qualified electricians who are familiar with the NEC and local electrical codes. An electrician can ensure that the work is done safely and correctly and that it meets all applicable requirements. Attempting to do electrical work yourself can be dangerous and can void your homeowner's insurance policy. Staying informed about electrical safety is an ongoing process. New technologies and safety concerns are constantly emerging, so it's important to stay up to date on the latest developments. There are many resources available to help you stay informed, including the NEC, online forums, and educational courses. By taking the time to educate yourself, you can make informed decisions about your home's electrical system and protect yourself and your family from electrical hazards. It is recommended that homeowners review their electrical systems periodically, especially in older homes, to identify any potential safety issues and ensure compliance with current codes. A professional electrical inspection can provide a comprehensive assessment of the system and identify any areas that need attention. Investing in electrical safety is an investment in the well-being of your family and the protection of your property. By taking the necessary steps to ensure that your electrical system is safe and compliant, you can reduce the risk of electrical shock, fire, and other hazards. The transition from the 1976 NEC to the present day highlights not only changes in specific requirements like GFCI outlet placement, but also a broader shift in how electrical safety is approached. The earlier code, while addressing certain risks, operated under a different set of assumptions about household electrical usage and the types of appliances commonly found in homes. The increased reliance on electronic devices, the proliferation of small appliances, and a greater understanding of the potential for electrical hazards have all contributed to the stricter requirements of modern codes. When considering the placement and requirements for GFCI outlets, it's helpful to think about the specific risks they are designed to mitigate. In bathrooms, the presence of water from sinks, showers, and tubs creates a high-risk environment for electrical shock. The requirement for GFCI protection in these areas is intended to protect individuals from coming into contact with energized electrical components while wet. Similarly, in kitchens, the combination of water, metal appliances, and conductive surfaces makes GFCI protection essential. The requirement for GFCI protection for countertop outlets and those within 6 feet of the sink is based on the likelihood of water splashing or spilling onto these surfaces. The use of dedicated circuits for GFCI outlets is also an important safety measure. By isolating these outlets from other circuits, the risk of a fault in another part of the electrical system causing a GFCI outlet to trip is reduced. This helps to ensure that the GFCI outlet is always ready to protect against ground faults. When evaluating an older home's electrical system, it's important to consider the age and condition of the wiring. Over time, wiring can deteriorate, become brittle, and develop cracks or breaks in the insulation. This can increase the risk of electrical shock and fire. If the wiring is old or damaged, it may need to be replaced. In addition to the wiring, it's also important to inspect the electrical panel. The electrical panel is the central hub of the home's electrical system, and it contains the circuit breakers or fuses that protect the wiring from overcurrent. If the electrical panel is old or outdated, it may not be able to handle the demands of modern appliances and electronic devices. It may also be undersized for the home's electrical needs. If the electrical panel is old or undersized, it may need to be upgraded. Finally, it's important to have a qualified electrician inspect the home's electrical system to ensure that it is safe and compliant with current codes. An electrician can identify any potential hazards and make recommendations for repairs or upgrades. They can also provide guidance on how to maintain the electrical system and prevent future problems.